Hello everyone, I'm back with my next lesson. So I'm on 8-2 and this is on page number 652. Okay, so we are learning about conic sections. So far we have done circles, and today we're going to be learning about our next conic section, which is an ellipse. So conic sections. And our today's lesson is on an ellipse. What is an ellipse? So let's talk about that. First of all, circle, as you guys already know, circle is something like this. And there's a center point always in the middle. And then every single point on the circle is actually same distance from this center point, which is called the radius. I hope you know that. Okay. So, but when it comes to an ellipse, it's slightly different. It's type of a circle. It is a type, but it's slightly different. So how's that different? So let's talk about that. When it comes to an ellipse could be like this. It's oval. Could be like this. Okay, I'm not a best drawer, but anyways, I tried. So if it's an ellipse, basically there is no center point, because if let's just estimate it. So let's say if I estimate it like this, okay, let's pretend this is a center point. So do you think all points on the circle are equidistant from this point? No, the answer is no, it's not, because what I see is this ellipse, it's bigger on the x-axis and it's smaller on the y. So if I look at this one here and try doing the same thing here, this is my center point, but this is not same as circle. So now I see the y side is bigger than the x-axis. So that's the difference. So from this, I can actually, this implies like an ellipse never have any center point. So there's no center point. So what I want you to do is just to understand the basic shape of this ellipse. I want you to look at the other video I have posted online. So that way you can actually get an idea about like how come there's no center point. Instead, we have two center points. So please pause this video and watch that first, and then we'll come back and we'll talk about the rest of the things. Okay, so I hope you guys understand the basic shape after watching the other video. Now let's talk about rest of the vocab terms you needed to know. So, as I said, one side is bigger. So it means there should be a different name for that. So, for vocab terms, so here comes the first vocab term. So we have major axis. When I say major axis, so the longer side of that ellipse is called major axis. If I see an ellipse like this, the y side is bigger than x. So y would be your major axis. If that ellipse is like this, it's bigger on the x-axis, so x would be major axis. So I would say the longer side or longer axis is called major axis. Okay, so pretty obvious, if major is the longer one, then the shorter one's going to be minor, so minor axis. So if I have something, if I see something like this, I see y side is bigger. If y is my major, so x definitely going to be my minor axis. Okay, that's the first thing you needed to know. Okay, a few other terms. Not a few, actually, we have a lot. So today's lesson, I would say more, it's like taking notes. So please take notes. I would really recommend you doing it, because for rest of the sections, you really needed to know these terms, all of these terms. Okay, so please do so. Anyways, so a few other things. Okay, so let's say for this ellipse, the bigger side is x. So I see these two endpoints. So these endpoints are called vertices. One singular, it's vertex, but since we have two, so plural is vertices. So these endpoints of the major axis is called, I would say, vertices. When it comes to minor axis, so endpoints of the minor axis, are called co-vertices. So these are the names. Okay, now next let's talk about the equation. How do we write down the equation for an ellipse? Normally try to calling if it's circle, so it's x squared, y squared, and it's equal to r squared. Just because it goes on same distance both ways, so that's the reason x and y, it just stands at itself, right? There's nothing else, there's no other number. So it means when it comes to ellipse equation, there has to be something that should describe the length of each axis. I hope that makes sense to you, right? So if it's an ellipse, the equation would look something like this. Let me just put a line in the middle because we have two different types, because it could be x-axis that's bigger than the y, it could be y bigger than x, so either or. So let's say I have x squared over a squared, y squared over b squared, and it's equal to 1. That could be one way that equation can be written. And x squared over b squared plus y squared over a squared. Okay, now let's try understanding. When the equation is like the first one, like this one here, let's pick darker one. Okay, basically the number under each variable tells you the length or how far that number is from the, I would say, how far it goes on that axis. So the bottom number describes the distance on that axis. So let's say, oh, my bad. So that describes the distance. So let's say this, I'm just going to draw that. Let's say this ellipse is like this. And let's say this is my x-axis and this is y-axis. So on the x-axis, it's going 5 units on both sides. So this is at -5 here, this is at +5 here. So I know on both sides it's going by 5 units. So once I have to write my equation, so it would be x squared, and it would be, okay, a is the distance, but for the equation you need a squared, so I would do 25. Okay, let's say on the y-axis, it's going by 3 units. So 3 here, -3 here, so y squared over, so distance is 3 and then square, so this would be my equation. So I repeat, basically the bottom number describes the distance on that axis. So if the bigger number is under x, means x going to be the major axis. Okay, keep in mind, a is the bigger number all the time. It's the bigger number. Oops. A is the bigger number, or the distance, I would say. So if a goes under x, so x is the major axis. If a goes under y, so y is going to be the major axis, like this one here. So I see a under y, so y is going to be a major axis, okay? So keep in mind. Next one. There are a few other things you need to understand. Oh gosh. So how do we label co-vertices and vertices? Let me just erase this part here because I need to label that. So co-vertices, how do we label that? So since, let's just say, I'm still going to use the same numbers I had before. So pretend this is 25, pretend this is 9, right? So since the vertices is always going to be on the major axis, right? So major axis, by looking at this here, by looking at the bottom number, I know x is the major axis. So my vertex is going to be, I would just say, I would take the number because x comes first and comma 0. So these going to be my vertices. What about co-vertices? Co-vertices is actually the endpoints of the minor one. So minor goes with b value. Since the y is minor, so I would do 0, comma, plus and minus b. If it's other way around, so vertices for this type of equation, since major axis is y, so your vertex is going to be 0, plus and minus a. Co-vertex is going to be plus and minus b, comma a. I hope you understand this part here. Okay, so that was just about these terms here. We still have a few more, and then I'm going to show you one example. Okay, as I said before, like this is unlike a circle, it will have a center point. So instead we have 2 points which it goes around. So an ellipse goes around 2 points. After watching the other video, you should know why. So these points, what are these 2 points? So one point in singular, I would say, that point is called focus. But since we have two, so the plural is foci. So these points are called foci. How do we solve for these foci points? And what is the symbol? So just because we have A and B for these numbers here, for foci, we have a symbol, we have letter C. For foci, we use letter C. How do we solve for those points? So there's an equation. So C squared is equal to A squared minus B squared. So some of you guys might gonna think that this is a lot of equation we need to remember. But here's the shortcut. So since the original ellipse equation has plus in there, so the foci equation would have minus in there. So it's always opposite. You'll understand once you get to see rest of those conic sections. You'll see this pattern would help. Trust me. Okay, so another thing you needed to know, these foci always going to be on the major axis, always. Foci always lie on major axis. So let's say X is the major axis. I'm just going to say, let's say X-axis is the major axis. So how would you label that? So X-axis, so number comes first, so I'm going to say plus and minus C comma 0. If Y is the major axis, then it would be 0 plus and minus C. So that's how we label it. So finally, let's get into an example, and I hope that will make more sense to you. So this is my example. I have x squared over 3, y squared over 25, and it's equal to 1. And keep in mind, ellipse equation is always equal to 1. So if you have to graph this, you need to find vertices, co-vertices, and foci at the end. First, just by looking at this equation, I see bigger number is under y. So I know it's going to be more like this. Let's just plot it first. How do we do that? So the center point of this one, I know there's no center point, but we just say there is a point that goes in the middle, right? Not exactly, not literal middle. It's just something that goes in the middle, where those two x and y is going to intersect. Okay, so basically, there's nothing with x and y. Normally, you will see h and k. I'm going to talk about those equations in the next lesson, but right now, I'm just going to say there's nothing attached with x and y, so center point would be at 0. So y squared has the bigger number, so it means I need the distance. And remember, this number going to be your a value, but this is a squared and this is b squared value. But in order to see on the graph, remember, you just need a and b value, not the square. So what would be your a value? So a is 5. So on the y-axis, you gotta go by 5 units, both sides. And what about the x-axis? So 3 is actually b squared. So what is the b value? So take square root, it's 1.73. So on the x-axis, you're going by 1.73. And finally, if you connect these points, that's going to be the graph of this ellipse. Now, time to label vertices, co-vertices, and foci. So vertices always on the major. Remember the endpoints of the major one. So since it's on the y, so my answer would be, okay, co-vertices, endpoints of the minor one. So it's plus and minus 1.73 comma 0. Almost there. Now time to find foci. How do we find foci? So try recalling the equation. It's c squared equation. C squared is equal to a squared minus b squared. Okay, now I need those numbers. Do I need to take square of 5 and 1.73? So answer is no. Why not? Because in the equation you already have a squared and b squared. So just take those numbers as it is. So c squared, what's the a number? 25. What's the b? It's 3. So c squared is equal to 22. C, just take square root, so I'm just going to estimate it's 4.5. All right, now foci always going to be on the major axis. Since I know major axis is y, so my foci would be somewhere around here. How would you label? So my answer would be plus, it's 0 plus and minus 4.5. Here you go. So that's how we deal with these kind of problems. So again, if you don't understand, pause the video. Please try going slow. I know it's going to be a little longer video, but I tried to cover as much as you guys needed to know. If you still have any questions, so please shoot me a comment. I'll just answer that. Thank you guys. Thank you for watching. Bye-bye.